Okay, in this video, let's take a look at grabbing the six basic trig functions. So in this first one, I want to look at y equals sine x. Okay, so we know the period is 2 pi, so we can break that up into quarters. And we'll go this direction too. Alright. So we know y equals sine x, so starts at 0. We'll go ahead and put the 1 in here. And the amplitude is 1, so it goes to 0 to 1 to negative 1. So it goes from 0, quarter turn up, it's 1, goes back to 0, down to negative 1, and back up to 0. Okay, going the opposite direction, so we go to negative 1 to 0 to 1, back to 0. Okay, so we get this nice little sine curve, best I can. Okay, so this is y equals sine x. What I want to compare this to is y equals cosecant x, or 1 over sine x. So since it's 1 over, we're going to note that anytime the sine is equal to 0, we're going to have asymptotes. It's going to be undefined. It will be over 0. So, go ahead and draw these in. Alright. And then we're going to take these points here and we're going to flip. So in other words, we're going to go okay. Alright, this is going to be y equals cosecant x. Alright, now let's take a look at cosine. Cosine again has a period of 2 pi. Okay, so this is negative 2 pi. And this is 2 pi. Okay. Of course, this is 1/2 pi, pi, half pi, and 0. So it also has an amplitude of 1. So I'll put in my negative 1 and 1. Okay. And this one starts at 1, goes to 0, goes down to negative 1, back up to 0, back up to 1. Okay, let's also note, if we go back real quick, that the sine is an odd function, right? So the sine of negative x is equal to the negative sine of x. Okay. Now here, going in the opposite direction, well, so it's going to start up here. So this one like that. This one like so. Okay. So this is y equals cosine x. Alright. Now, again, everywhere the cosine is 0, if we do 1 over cosine, those are going to be undefined. So that's going to be the secant x we're going to look at. So everywhere this is 0, cosecant's secant's undefined. So just like we did with the sine, these points are going to get flipped up. Okay. So there you go. And of course you could do translations. If you put a 2 in front of it, you multiply the y values by 2. You can change the period, and you can flip it over the x-axis as well. So y equals secant x. Okay. Next, I want to look at the tangent. Okay. Now this one has a period of pi. It's a little different. So here, pi halves and negative pi halves. Okay, so that's one complete one. These are asymptotic here. So basically, it has a period of pi from negative pi halves, oops, to pi halves. Okay. All right. So we know that tangent 0 is 0. Okay. And at pi over 4, or 45 degree angle, it's 1. So let me go ahead and put these in. 1 and negative 1. Okay. So one here and negative 1. And again, these are at pi over 4 and negative pi over 4. So this one comes up from negative infinity, goes through the origin, and curves up. Okay. And then so let's go ahead and take a look at the cotangent. Notice that cotangent is 1 over tangent. Let me go ahead and write this in. So cotangent is 1 over tangent. And when you do 1 over, a couple things are going to happen. First of all, this point is still going to be there. Okay. And this point is still going to be here. But now what happens is this 0 becomes asymptotic. Okay. And the other asymptote goes over here. Okay. And so this thing's going to flip. It's going to be 0 right here. Okay. It's going to be 0 right there at pi half. So it's going to come down kind of like that. Okay. And like that. Okay. So in the blue we have y equals cotangent x. All right, thank you.